Alright. In this video, I'm going to be discussing something I've been kind of working on off and on here. It's an old FDK MULTI-2700 2-meter PLL transceiver, all mode FM, wide narrow USB, lowest sideband CWAM, and I got it to where it's working halfway decent right now, but I was gonna give you an overview of some of the problems I had on it when I got it. I had the normal annoyances like the dial meter 9 dial lights not working, or meter lights not working, which those are easily changed. And some of the more important annoyances was when in VFO mode it was way off. I mean, totally in another band. When I was in the 146, 147 megahertz selection, I was literally, the TX frequency and RX frequency was literally going up into the LMR Land Mobile 150, 153 megahertz range, and it was in the fixed frequency synthesizer mode. Then the frequency is correct, but whenever I went to the VFO mode, just totally off the wall. And the other problem it had was the transmit section was the finals were completely unstable. Whenever you push down the key, and when you was in either lower sideband, upper sideband, or whatever, then it just basically, the finals or the transmit section would take off pretty much uncontrollably, transmitting at some odd random frequency and stuff. When you was in FM narrow or FM wide, it seemed to behave itself, but whenever you turn to a mode where the final set unloaded, whenever you was between words and stuff, then it just literally take off in self-oscillation. I'll give you an overview of some of the things I had to do to get it fixed up to this point, and some of the issues I'm still troubleshooting on it. Alright, as you can see, I've got the radio setting on its back with its belly up to the world. Now to describe what I had to do, figure out what was going on and the problem on the tuning of it, I have to give you a little bit of an idea what's going on with the PLL system and stuff on it. It's a bit complicated and I get my tongue tied once or twice trying to describe it. So this radio does not have what you'd think of as a normal VFO. It does not directly generate a signal that is directly mixed into the receive and transmit chain somewhere. It uses a VFO that serves as a time base for the PLL. When you're tuning the frequency or whatever, it shifts the whole phase lock loop system with it. When you're operating normal synthesizer operation via these selectable switches, then the PLL system runs off of a fixed frequency base, and these switches choose the divisor ratio between the fixed reference and the PLL generated frequency and stuff, so it's in adjustable steps, fixed steps from the reference to the generated frequency, which is mixed in. But when you switch to VFO mode, the divisor becomes fixed, and these knobs of course don't have any effect, while the reference frequency is shifted over to the VFO, and that causes the whole PLL chain to shift when you change the VFO frequency. Thus, when I noticed that the signal is way off with this, I knew I had to check its output where it went into the PLL system, and its frequency in reference to the normal fixed reference. And when I took and checked the frequency output of the VFO block itself that feeds the PLL system, I found out that the frequency was way off from where it should be. And when I took the cover off, I found two bad fixed capacitors in the VFO, and to understand how this VFO works, it's also quite complicated, kind of like the PLL system itself. Is the VFO has two sections, two gangs, and one kind of pads the other. Reason why is because they did not use a variable or linear gain capacitor to produce a linear tuning response. They used a straight cut gains on this capacitor, so to produce a linear tuning response they have to have a second gang which is tied via these trim caps to produce a linear response. And it looks like they didn't really design into it the how do I say this here? They didn't design it so that it would be pretty much on frequency with just stock components there and stuff. They designed it so once they build it, they would pad out the capacitor and stuff to obtain the desired frequency. And as you can see, a whole bunch of small capacitors here and there. I evidently done it at the time of construction, so probably every individual radio is a bit different. They added a couple bulk capacitors to get it within range, and then once they got it close, then they started adding smaller disc capacitors like 22 PF, 7 PF, and 6 PF to get it where it's in the center of the air variable trimmer capacitor tuning range. And on this one here, two of the big film bulk capacitors they put in place, this one here and here, went bad. When I checked them, they had no effect removing them, so I pulled them out. Found a 75 PF capacitor, pretty much brought it within the center of the air variable trimming cap range. Pretty much padded it out nice, so left that in. Just when I found it worked, I just left it where it was at and been done with it. And the little small value caps going to the second gang, I didn't really find anything wrong with those. The tuning range is linear and stuff, so I left that. It's just strictly the bulk caps going from the primary gang to ground, was a couple of them went bad. Stuff, of course, I had to take and adjust some of these potentiometers here because a couple of those, and of course, drift from age, had to get just a couple to get the receiver incremental tuning and stuff straightened out properly. Well, other stuff, you can see over here, it's someone had a home built, it looks, preamp they put in it. Bit sketchy in my opinion, but it seems to be working fine, so I just left it in place to this point. And of course you can see the 29 megahertz up converter. Of course this rig is intended for satellite operation, so that converter was designed for the standard Oscar split at that time. And the now on to the other problem that I had with the instability in the final amplifier section. Flip the radio back over and I'll see you there. The other problem, as I said, which is harder to straighten out on this radio, was instability in the final amplifier section whenever I was operating with low output power, or in a mode where you had no output between words or a CW key or whatever. Then the output section would go into self-oscillation, and of course this here is the output section, and includes the final output amp and the driver, and here's the preamp. Of course the final mixer is right here, preamp, and it jumps over to this cable driver, and the final, then you have a matching section, then you have the SWR detection network here, which when I dug into this I found that there were several solder joints that had come loose in various places. I had to literally pull the whole section out and redo some solder joints on the back side and this side and whatever to try to get everything tidied back up. When I put the unit back in place, it seems to be stable, relatively rock stable, whenever I have it into a matched antenna or 50 ohm load. Don't seem to have any problems with stability on the or spurious emissions on the transmit signal, but still having kind of a running issue whenever I have it into a poorly matched antenna with high SWR of various degrees. Then the section will still break into spurious operation, which I went back over all the solder joints and stuff, and I at this point in time don't know where the signal is leaking back into the final section, because on this radio they don't really use neutralization of any form on the final amp. They're relying on brute force isolation to maintain stability, which it's failing somewhere, and I've got to find out exactly where. Now there's a possibility here, because the signal could be getting in anywhere from here all the way up to here. It might be a failed bypass cap or feed through cap on one of these several bias and VCC feed through points, or it could be, which more obvious possibility, it's failed isolation cap on this board here, and somewhere on the preamp stuff here, right after the final filter section and stuff, where it changes to the final transmit frequency. It could be this one or that one. I've got to poke around on it a bit, put it into a situation where it'll break into oscillation, and see what I can bypass out or whatever to get it to drop out, and it'll give me an idea. Now these solder joints here look to be in good shape and stuff, but I'll probably go over those again, because it could be a hairline crack on one of the ground connections or something on the final transistor and stuff that could be causing issues that I cannot see or not really detect visually, but I'll just go over those and a couple other solder joints to make sure. But beyond that little instability when running into a mismatched antenna, the radio seems to be back to general full functionality again. So just a little bit more troubleshooting, and this old sucker will be back to the state of functionality again. So take care. Take it easy.